In this lesson, we're going to learn about solving multi-step inequalities. So what I've done to start is I gave you an equation, notice equal sign, just for a little warm-up here. Go ahead, try to solve that. And what I would recommend you do, push pause right now, because I'm going to put all of my work and all my answers up right now. So if you look through, I've solved that equation step by step to end up with a final answer of c equal to -3. So if you need it all the work there, go ahead, push pause, and you can compare to how you solved your equation. Now remember, there's multiple ways that we can get there, some different work that we could have done, but in the end, we should all end up with c equal to -3. Now I have one more here that I'd like you to try. And again, go ahead, push pause, and you can solve that equation, and then in a few seconds, I will put all of my work and my answer there. So push pause now. And then again, there's my work and my solution for that one. Now, getting into solving these multi-step inequalities, really not any different than solving those equations from the previous slide. The only difference is we have the inequality symbol right here instead of an equal sign. Let me get rid of that so it doesn't look like it's we have the equals to part. So I'm going to go ahead, the first thing I'm going to do here is I'm going to distribute because I don't want the parentheses. Now this is the one that sometimes gets some of us, that negative right there where we're subtracting all of the stuff inside of the parentheses. So when I distribute that, I'm going to start with the 8 because we had that, and then we're going to subtract the c because we distribute to the positive c, and then we're going to subtract 3. It's going to be less than 6c. And again, here I'm going to distribute, so I'm going to add on 6, and I'm going to add on technically a -3c, which would be the same thing as subtracting 3c. Now I'm going to put my like terms together on each side. I'm going to bring the c first, and then I'm going to have +5, because these two are going to go together. On this side, I'm going to have my c's, or like terms, so I'm going to end up with 3c and then plus the 6. I didn't do anything to either side other than simplify, so my inequality sign is going to stay as is. The next thing I would like to do is I would like to get my c's to one side. So what I'm going to do is I like to have my variables on the left side most of the time, so I'm going to move mine over here. And then I'm also going to get my constants to the right side. I'm going to do this in one step. If you'd like to do it in two, you sure can. So I'm going to go like that. 2 steps in one. So now I end up with -4c on the left side. Notice my 5's are all gone, constants are gone. And on this side, my c's are all gone, but now I'm left with 1. And since I was just adding, technically subtracting the same thing from both sides, my inequality sign does not change. Now I'm going to divide both sides to get the c all by itself. Now here's the part that we have to remember. When we multiply or divide by a negative, going back to some previous lessons, remember that sign is going to have to change directions. Left side, c, right side, -1/4. So I've found the solution to that original inequality. C is greater than -1/4. I'm just going to write it in set builder notation as well so that we're familiar with that and we don't forget about that. So it looks just like this. So remember, you have your squiggly parenthesis and then c, the variable, such that c is greater than -1/4. All right, my next one. Not really any different. I just like to throw a fraction at us so that we stay fresh on those. In this one, I'm going to subtract the 5 from both sides. So now we're left with 2/3 m. And we're left with 12 on this side, subtracted, so our sign stays as is. Now I need to get rid of the 2/3. So remember, if we multiply by the reciprocal, the 3's in the numerator and the denominator, those are going to divide out, become 1's. The 2's in the denominator and the numerator divide out, become 1's, so all we're left with is the m. And since I multiplied the left side by 3/2, I have to multiply the right side by 3/2. And then I'd look at this and go, my 2 is going to become 1, the 12 is going to become a 6, and 6 times 3 is 18. I multiply both sides, but again, it's a positive, or I multiplied by a positive, therefore I don't change the sign. So I have m is greater than or equal to 18. If we put that one into set builder notation, squiggly parenthesis, tell the variable that we used such that, and then m is greater than or equal to 18. There we go. Next one, I have a word problem here that I think is going to be pretty straightforward for us. We're just going to go through it. I'm going to read it. And the first thing it says 4 times a number plus 12 is less than a number minus 3. So the first thing I want to do is I want to write an inequality to represent that sentence. And then once I have it written, I'll be able to solve it. So to write it, I'm just going to start at the beginning and look for the important things. 4 times, so multiply. I may not need the little dot, but I'm going to put it there for now. Now I have a number, which maybe I should have started with earlier. I don't know what that number is, therefore I'm going to have a variable for that. So I'm going to call my number, n is going to equal a number. And again, you can use any variable that you want for that. I just chose n because number starts with n. And then we go on, it keeps going on, and now we have plus, oops, you know what I forgot? I forgot to write down my number. There we go, and then plus our plus sign. And then we have, go with the 12, so I'm going to need 12 in here. And then we have the is less than. So is less than, that is our inequality symbol. And then here comes a number again. And then this time we have to minus the 3. Coming back here, I'm going to go back to this and go, do I really need that? No, so I'm going to get rid of that just to clean it up a little bit. Slide this over, and there's my 4 times a number plus 12 is less than a number minus 3. We have an inequality that we can solve. So I'm going to go through and solve that. Like I said, I like to have my variables on the left side, so I'm going to subtract the n from both sides, which means I'm going to get all my constants to the right side. Therefore, this 12 has to go away. So I'm going to subtract 12 from both sides. Again, I'm doing 2 steps at once. If you'd like to break that into 2 steps, you go right ahead. So now I have 3n is less than negative 15. And to finish this one out, I'm going to divide both sides by 3. And we just found out that n is less than negative 5. And again, I could put that into set builder notation. So n is our variable such that n is less than negative 5. And we solved that little word problem. On my last slide that I have here, I have 2 special types of inequalities, or the solutions that we're going to get are a little different than what we're used to on the other ones. Give you a little hint of what's coming there. But what I'm going to do is I'm going to solve these just like I have any other ones. Parentheses, so I'm going to distribute. Negative 7b will be a plus sign then. It's going to be minus 28. And then plus the 11b here. And then still have our inequality symbol, 8b. Now I have to distribute. Be careful, that's a negative 2 that I'm distributing. So I'm going to have minus 4b and minus 2. All right. Now let's simplify each side. I notice I have b's and b's. That's going to put me at 4b minus 28 on this side. It's greater than, and I have b's and b's here, so I have 4b minus 2 on this side. I'm going to get my variables to the left side like I always do. Or not all, I shouldn't say always, most of the time. And I'm going to get my constants to the right side. So when I get to this point, I notice that it says, well, this side's 0 now, and the right side is 26. My inequality sign wouldn't change, and it looks like that. And hopefully some of you have noticed that there's no variable anymore. So now what I have to do is I just look at this inequality at the very end right here. 0 is greater than 26. You should be saying, well, that's not true, and you're right. So this inequality right here is false, which means every inequality above it, this inequality here in the red, would also be false, and so is the blue one, all of that, and so is the original pink one. All of those are false. Well, if it's false, what does that mean? What that tells us is there are no real solutions. In other words, there's no numbers that are going to work in that. And sometimes you're going to see that written this way. They just do this 0. It looks like a 0 with a slash through it. What that really means is the empty set, which says the set of solutions has nothing in it, so it's an empty set of solutions. So when you solve an inequality and you get to the point where there's no variable left and your inequality is false, well, that means that there's no real solutions. There's no numbers that are actually going to work in it. And then I have one more example here. Go through and solve this one. So my left side, I noticed that I could put like terms together right away. So I'm going to put my n's together, and I'm going to end up with 2n. And then I'm going to put the 8 and the negative 7 together to get a positive 1. Less than this side, I'm going to have to distribute. So I end up with 18 plus 2n, and then I still have the minus 3. I'm going to put these like terms together right now here and here. So I end up with 2n plus 15 is less than, and this side doesn't change. There we go. And then again, I like to move my variables to one side. And I'm just going to do this. I'm going to do it kind of, think of it as one step at a time. This time I end up with 1 on the left side and 15 on the right side. Since I was just subtracting on both sides, my inequality sign stays the same. Now notice, variables are all gone again. But now this time I have an inequality that says 1 is less than 15. That inequality is true. Well, what does that mean? What that tells us is it doesn't matter what number we put in for our variable, for n, wherever that is, it's going to make the inequality true. And what I like to look back at too is, I'm going to look back to the red inequality. I look at the red inequality and I notice that I have 2n on both sides. So I don't care what number I put in for n, the part that I have circled is always going to be the same number. So on the left side, if I add 1 to that number, obviously it's 1 bigger. But on the right side, if I add 15 to it, that's going to be 15 bigger. Therefore, the right side of this inequality is always going to be bigger, and the left side is always smaller. Since we have the less than in there, left side is smaller than the right side, always true. Therefore, what we do for our solution is we say that the solution is all real numbers. Any number is going to work. You can put it in it. Now, if you want the abbreviation, that's the all real number symbol, an R with an extra leg. And that's going to end our lesson on solving multi-step inequalities. I wish you the best of luck with it.